Hello everyone, so today we're going to take a quick look on a dataset from Kaggle called Cyberbullying classification, where we have 47,000 tweets and 6 balanced classes. So balanced classes, it means that we don't need to do any transformation on our data to balance it, so it's easier for us. Let's see if there is some explanation here that you can look later, but these are the classes such as age, cyberbullying about age, about ethnicity, gender, religion, other type of cyberbullying, and not cyberbullying. And it says that we have around 8,000 tweets for each of the classes. Okay. And okay, and some of the tweets are offensive. Okay. This is a multi-classification model that we have to create. So let's jump right to the code. Wait one moment. Okay. Okay, so these are the modules that I am using. As you can see, we have TF-IDF, truncated SVD, stop words, some modules for modeling from sklearn, train and test split, random forest, and pipeline, and evaluation like classification report, row curves, and so on. Okay. This is the data set. We see we have only 2 columns, the tweet text, the text, and the labels. Okay, for the 6 classes. Overall, 47,000. Okay, let's do a quick EDA. We see that that the classes are balanced. And we also see here that the number of words in each of the texts. Okay, so I'm doing a real quick pre-processing. I'm using train test split here, and I'm using pointer stemmer because it's faster. Maybe it's better to use lemmatizer or other things, but pointer stemmer just for the speed. So I'm using text.lower, I'm removing URLs, special characters, multiple spaces, stop words, and I perform stemming here, and also removing tweets that have lower than 4 words. Okay, for the modeling part, I'm using pipelines for 2 models. For the first model is random forest, where I'm using TF-IDF, text into numbers. I'm leaving only 5,000 features here and see how it goes. And I'm also using the truncated SVD. It's a better use when you have a sparse matrix rather than using PCA. So I'm just leaving only the top 100 features. So from 5,000 features here, I reduced it to 100 features, and then I entered it as input to the random forest classifier. And I'm here using the prediction, and I'm also leaving the predict proba for later use for the row curves. Okay, and with the row curves, I will compare the 2 models. Okay, so this was for the random forest. I'm using the same thing for the logistic regression, as you can see. Okay, and these are the results using the classification report. We see that for some classes we're doing pretty well, but for others, like not cyberbullying or other cyberbullying, we're doing less better. So our overall accuracy is 0.81. Okay, and we can also see this is for the logistic regression, and this is for the random forest with accuracy of 80%. And we have the same problem. See, we're not cyberbullying, and other cyberbullying are performing less. The model performs less better here. Okay, now, when I want to use a comparison with row curves between the multi-classification models, I first want to use the label binarize on the Y test to make it suitable and has the same output like the predict proba for both models. So in this case, we have for every class we have a column, and you can see that for the correct predicted class here, for example, in the first row, correct predicted class was class number 3, like 1, 2, 3, and the rest are zeros. So after using this output, using label binarize, then I go and compare the 2 models. But first, I'll just want to compare the Y test and the predict proba for logistic regression only, and then I can see the row curves for each of the classes. And you can see that we did really well here in the religion, but did very, very poorly in the age. And that's how we can understand how the model performs for each of the classes. I did the same thing for the logistic regression, you can see here. And in this chunk of code, and what I'm doing is I'm comparing the two models. So you can see the performance for class other cyberbullying, for the logistic regression and for the random forest. So you see that the logistic regression model performed better for this class. And you can go and compare each and any of the classes and see which model does better, and then by doing that, you can also try to understand which one you want to use.